right, I am going to do a video on answering optimization questions that I got from folks in class. Okay, so these are going to be problems from the book, and I have the book over here, and I'm going to do number 1 and number 11, 12, 16, 17, 20, 22, 24, 20, 24, 36, 41, 53. And anyway, so we'll see. I'll try to be as fast as I can. All right, so question number 1 says the sum, it's over here, the sum of two non-negative numbers is 20. Find the numbers if, okay, so the sum of two non-negative numbers. So we could say that one of the numbers is x and one of them is y, so x plus y equals 20, right? That's the sum of two non-negative numbers. So we could say one of the numbers is x, and the other one is y, but we can say that y equals 20 minus x, right? So theoretically, the numbers can be x and 20 minus x. All right, so the sum of their squares is as large as possible. So the sum of their squares, so I'm going to create a function f of x, which is the sum of their squares. So it's going to be x squared plus 20 minus x quantity squared. All right. And if I want to find they're as large as possible or as small as possible, I need to find the derivative in critical points. All right, so let's take the derivative. This is going to be 2x plus power down function lower the power 1, which is to the 1, and then to the negative, and then times the derivative of the inside, which is negative 1. All right, so I'm going to set it equal to 0. We get 2x plus 40 minus 2x, but then this is times negative 1, so we're going to make this a negative and this a plus, right? Because if I distribute to negative. All right, so that means we're going to get 0 equals 4x minus 40. 0 equals, I'm going to factor out a 4, and I get x minus 10 equals 0. So I know that my critical point is at 10. So if I do an f prime line, I'm going to put 10 in here. And now, let's talk about the constraints. My numbers have to be non-negative, right? That means x has to be greater than 0, and 20 minus x has to be greater than 0. X could be greater than or equal to, because non-negative means that it could be 0. Okay, so that means that if I were to do this reduction here, that would be negative x is greater than or equal to negative 20, and then x has to be less than or equal to 20 if I flip the sign here. So that means that x has to lie between 20 and 0. So that's a closed interval, believe it or not, 0 to 20. And if I were to superimpose this graph right here, 4x minus 10 is a line with a positive slope. So if I superimpose the graph on here, I know this is my 0 at 10. I have negative y values on the derivative and positive y values here, which means if I were to do, the little slope thing that we do when we analyze the slopes, let me get my pens out here. I have a negative slope to 0 slope to a positive, so that's a minimum. But since I have a closed interval, I got to check the endpoint. So here we go. X, and I'm going to put 0, and I'm going to put 20 here, I'm going to put 10 here, and then I'm going to check my y values of my original function, which is x squared plus 20 minus x squared. 20 minus x quantity squared, okay? So when I do that, when I plug in 0 here, I get 0 plus 20 minus 0, which is 20 squared, which is 400. When I plug 10 in, I get 100 plus 20 minus 10 is 10. 10 squared is 100. So this is 200 when I add those together. And then 20 squared is 400 plus 20 minus 20, which is 0. So this is 400. So the numbers are for the absolute max here occurs when the numbers are 0 and 20. And the absolute min occurs when the number x is 10. So if x is 10, the other number has to be 10, right? So the numbers for the min are 10 and 10. And for the absolute max, the numbers are 0 and 20. And the chart is my justification. All right, so that's number 1, part A. So let's look at part B. Part B says, I'm going to make it a little bit bigger so we can see it. Part B says one number plus the square root of the other is as large as possible, as small as possible. Okay, so one number plus the square root of the other. Well, if I have one number as x and the other is 20 minus x, there's an easy way to go to solve this problem, and then there's a more difficult way. All right, well, I'm going to try to go the easy way. So if I have two numbers, x and 20 minus x, I'm going to take the square root of the easier one. So let's set up our function. We'll say f of x is equal to the square root of x, right? Because it's the square root of one of the numbers. One number plus the square root of the other. So we're going to add 20 minus x, right? One number, which is this one, plus the square root of the other. That's our function. So let's do f prime here. Well, that's x to the 1/2, which would be 1/2 x to the negative 1/2. Plus the derivative of this. The derivative of 20 is 0. The derivative of x is negative 1. So I'm going to have 1 over 2 root x minus 1. Set that equal to 0 because that's my derivative. And then when you do that, you have to find a common denominator here, which I hope you all recognize is 2 root x. And so this will be 1 minus 2 root x because I multiply this 1 by root 2 x over root 2 x. Root 2 root x. I'm trying to say that really fast, 3 or 4 times, okay? And so to find the zeros here, I'm going to set the numerator equal to 0. So we get 1 minus 2 root x equals 0. So we get 2 root x equals 1. Root x equals 1/2. If I square both sides, I get x squared equals 1/4. I'm sorry, not x squared, but x equals 1/4. So if x is 1/4, the other number is 20 minus x. Which is 19 3/4. Okay. All right, but I got to do a sign chart to make sure we're right. Okay, so this is maybe my f prime line. So what goes on there? 0. I'm sorry, 1/4, which is 0. I have a critical point where it's undefined at 0, so I put a 0 here and undefined. My domain is going to be from 0 to infinity, right? Because obviously I can't take the square root of negative numbers. So I'm going to superimpose the numerator here. When I do that, 1 minus 2 root x, or let's just plot a point, shall we? What happens when I plug in, we can plug it in this unsimplified version. What happens when you plug in what's less than 1/4? 1/8. Well, let's do 1/9, right? Because if I put in 1/9, I can take the square root of 1/9. So we go 1 over 2 times the square root of 1/9 minus 1. All right, that's going to be 1 over, the square root of 1/9 is 1/3. So that's over 2/3 minus 1. So this 3/2 minus 1, which is 1/2. So this is a positive number here. Now let's choose a number to the right of 1/4. That's a nice square root, like 4. Would you agree with that? Yeah, 4. Okay, so let's try 4. If we want an interval over here, that would be 1/2 to root 4 minus 1. This is 1 over 4 minus 1, which is equal to negative 3/4. So it's a negative number over here. So this right here is if I were to do my little slope thing, my slope analysis, that right there is a maximum. Then again, we're going to use a little chart as our best friend here. Here we go. And I'm going to put x, and then I'm going to put the square root of x. plus 20 minus x. And what goes on here? My critical points and my endpoints. I'm going to put 20. I'm going to put 1/4 and, 0, 1/4, and 20. When I plug 0 in here, I get 0 plus 20 minus 0, which is 20. When I plug 1/4 in here, I get, what's the square root of 1/4? Well, that's 1/2 plus 19 3/4. Right? So if I'm adding 1/2, which is 2/4 to this, this is going to be 19 3/4 plus 2/4, which is 19 3/4 and 5/4, which means I can make this 20 1/4. Okay, and then when I plug 20 in, I get root 20 minus 0, and this is what, 2√5. So this is my absolute max here. So we can have an absolute max of 20 1/4 at one of the numbers x equaling 1/4. Because that's bigger than 20, right? And then at 20, that's going to be the absolute min. Absolute min of 2√5 at x equals x equals 20. And my justification again is my chart. So this is the absolute min. This is the absolute max. Because that's the highest y value. This is the highest, the next highest, and then obviously this is 2 times √5, which is just a little bit more than 2. So it's like 2 times 2 point something. So that's going to be the smallest number, okay? All right, so that's how you do the number 1. Moving right along. The next number is number 11. Let's find number 11. Designing a tank. It's right here. Your ironworks is contracted to design a tank and design and build a 500 cubic square. What 500 cubic? Let's talk about what that number represents. It's a cubic feet. 500 cubic feet. That's a volume. So they're telling you the volume equals 500 cubic feet. That's a volume. Okay. You're going to design a 500 cubic feet square-based, open-top, rectangular steel holding tank. So a square base. So here's my square base. Now it looks like a rhombus, but that's like because we're looking at it from the side, okay? And it's just got a square base and it's got a height here. Right? I'm trying to make my bases parallel here. And the top is open. So this is open. Square-based, open-top, rectangular steel tank for a paper company. The tank is to be made by welding thin stainless steel plates together along their edges. As a production engineer, your job is to find the final dimensions of the base and the height that will make the tank weigh as little as possible. All right, I don't know this dimension. I don't know this dimension, but it's a square base, so I'm going to call them x. And this is the height, and I'm going to call that y. Something that is going to weigh the least is going to be made out of the least material. So we're going to use surface area. We're going to minimize surface area. Okay, but volume of this thing, what does that equal? Volume equals the area of the base, which is x squared, plus the area of the 4 sides. Now one side is x times y, and we have 4 sides, so this will be 4xy. I'm sorry, try again. I'm doing the surface area already. Sorry, it's late. So volume equals the area of the base times the height, which is x squared y. I apologize. And that equals 500. We want to minimize the surface area because we want the lightest material. So let's do the surface area. Well, the area of the base is x squared. I'm not including the top because that's been indicated it will be open, plus the area of each one of these faces. And one of the faces is xy, and there are 4 of them, so it'd be 4xy. Now, in this equation, I have too many variables on the right. I have x squared and xy over here. But luckily for us, we have some information up here that will allow us to eliminate a variable. Okay, now I'm going to solve this for y because that's the easiest way to go. Because if I solve this equation for x, I'd involve square roots, and even I might be go screaming somewhere. But we won't. So y equals 500 over x squared, and I'm going to use this information and substitute into this equation. So I have a function of x only. So this is surface area equals x squared plus 4x times 500 over x squared. Okay, I can reduce one of these by 1, and I get surface area equals x squared plus 4 times 500 is 2,000 over x, because I got rid of one of them. Now I'm going to rewrite this as x squared plus 2,000 x to the negative 1, because I want to take the derivative of that instead of using the quotient rule here. So let's take the derivative. SA prime is equal to, well, that's going to be 2x minus, if I use the power rule, 2,000 x to the minus 2. Now I'm going to put things where they belong. We get 2x minus 2,000 over x squared. If I find a common denominator, that's clearly x squared. I multiply this 2x by x squared over x squared, and I get 2x cubed minus 2,000. Okay. All right, so setting it equal to 0, this lovely derivative. And if I have x equaling 0, then I don't even have a tank. So I'm going to, that's going to be a solution we're not going to use. So we're going to set 2x cubed minus 2,000 equal to 0. 2x cubed equals 2,000, sorry. X cubed equals 1,000. Well, 1,000 happens to be a perfect cube, so x equals 10. Here we go. We got to do an SA prime line, and I'm going to put a 10 on it, and it's a 0 here. The numerator is a cubic, and it's got a 0 that's got a multiplicity of 3. And well, it's a pass-through. So here we go. Here's my pass-through. I'm passing through. All right, this is my numerator. My denominator is always positive. It's x squared. Here it is. I'm superimposing it. Negative divided by a positive is negative. 2 positives on this side is positive. And so if I were to do the slope analysis, first derivative test, I have a negative slope to a 0 slope to a positive slope, which means I have a minimum, which is what I was looking for, because I want a minimum surface area. Now the question we have to remind ourselves is asking, I want the dimensions that the shop is going to use. Well, so if x is 10, how do I find y? Well, you go back to the original, and in the beginning, I said y equals 500 over x squared. So we're going to go such that x equals 10. So that's going to be 500 over 100, which is 5. So the dimensions of the tank that weighs the least should be 10 feet by 10 feet by 5 feet, since SA prime is less than 0 and then goes to SA prime is greater than 0 when x is 10 feet. All right, part B says, briefly describe how you took the weight into account. Well, you know, the weight is going to be the amount of material, okay? So if I have more material that I'm using, the heavier it's going to be. So if you say something along those lines, you'll be just fine, okay? All right, that's number 11. Let's move along. 12, I think, is the next one. Yep, number 12. Here we go. Number 12, catching rainwater. A 100 or 1,125 cubic open top rectangular tank with a square base. Here we go. This is a similar problem. So I have a rectangular tank with a square base. Okay, so I'm going to draw my square base. And remember, it looks like it's a rhombus because we're looking at it from the side. Oops. I should go up. That way would be better, right? And I'm going to make it my sides parallel here. You don't have to be a 3D artist to do this. You just, I've drawn enough of them, so I'm used to it, okay? So don't beat yourself up about it. Not a perfect sketch. All right, but it says it's open. Open. So this again is open. And this is x and x because it's square, and we don't know how high it is, so we're going to make it y. But they told us the volume is 1,125 cubic feet. And we're going to say that that's equal to the volume, which would be the area of the base, which is x squared times the height, which is y. All right. Now this one has a different kind of a classic feel to it because it says the costs associated with the tank involve not only the material from which the tank is made, but also an excavation charge proportional to the product xy. If the total cost is C equals 5x squared, 5 times x squared plus 4xy quantity plus 10xy, what values of x and y will minimize it? So we want to minimize cost, and they're giving you an equation, which is nice. So you don't have to come up with it from thin air. Plus 10xy. Now what I notice about this equation is that I've got two xy terms here. So I might make my life easier if I were to simplify and add like terms. So I'm going to distribute this 5 in. And we get 5x squared plus 20xy plus 10xy, which means the cost equation is 5x squared plus 30xy. Now I have too many variables on the right-hand side here, but conveniently, I have a volume equation that will allow us to solve either x or y to substitute into this cost equation. And again, there's an easy way to go or a more difficult way to go. So I suggest we solve this equation for y. So we're going to say y equals 1,125 over x squared. And we're going to take this information and substitute it in for y. So we're going to get cost equals 5x squared plus 30x times 1,125 over x squared. Now I'm going to simplify this before I do the derivative because it'll be a lot easier to do. And I'm going to get rid of 1x here and in the numerator and the denominator. We're going to get 5x squared plus, I don't know what 30 times 1,125 is, so I'm just going to leave it. And this is over x. Okay. So C equals 5x squared plus 30 times 1,125 x to the minus 1. Right, because I can do that. And I'm going to take the derivative now. Cost prime is going to be 10x. Now bring this down, minus 30 times 1,125 x to the negative 2. Putting things where they belong, I'm going to get 10x minus 30 times 1,125 over x squared. Okay, I got to set my derivative equal to 0. So I have to find a common denominator, which is x squared. So we're going to get 10x cubed, because I'm going to multiply this by x squared over x squared, minus 30 times 1,125 over x squared equals 0. If x is 0, my physical constraint, I don't have a box. I don't have a tank. Okay, so x equals 0 is not going to be one of my solutions, or I don't have a tank or a problem to think about. Okay, so I'm going to set the numerator equal to 0 again. So we're going to get 10x cubed minus 30, 1125. And we're going to set that equal to 0. Okay, well, I'm going to get 10x cubed equals 30 times 1125 over, okay, and then I'm going to divide by 10. So x cubed equals 30 times 1125 over 10. Okay, well, the zeros go away because 30 over 10 is just 3. So x cubed equals, this is going to be 3 times 1125. So I'm going to do that math. Here we go. It's 15, carry the 1, that's 7. And then we have 3, 3. All right. Now, that's 3375 over 1. Okay, now, I have done this problem a number of times, and, you know, I happen to know that I believe it's 15 cubed equals 3375, but let's triple check here. 15 raised to the third is 3375. But if you didn't know that, you could just leave it as the cube root of 33 or 3375, okay? So don't fuss with that. So x equals 15. All right, I got to know if that's a max or a min. So I'm going to do a C prime line. Here it is. I'm going to put 15 down. That's a 0. And the denominator and my derivative is just x squared. So here it is. I superimposed it. The numerator is a cubic with positive end behavior with 1 0, and the 0 is 15. So here's my cubic that I'm superimposing. All right, so I'm going to do my sign chart. I really wish my pinks were working more, but they're not. Oh well, I'll go with purple. All right, so when I do that, I have a negative divided by a positive, which gives me a negative. All right, and then two positives divided give me a positive. So if I do the slope analysis, I have a negative slope going to a 0 slope to a positive slope, which means I have a min, which is what I wanted, because we wanted to minimize the excavation and the cost of the tank. But the question says, what values of x and y will minimize it? So we would say the value, or x equals 15. Well, how do I find out what y is? Well, I still have some work to do, right? If x equals 15, we know that y equals 1,125 over x squared, right? Because that's a relationship we had from above. So let's say such that x equals 15. This is going to be y equals 1,125 over 15 squared is 225, right? And let's see really quickly what 1125 divided by 225 is. If you can't see that, that says 5. So y equals 5. So x equals 15 and y equals 5 will minimize the cost of the tank since cost prime is great or less than 0 and goes to cost prime is greater than 0. All right, so the first derivative test here is what helps that, okay? All right, let's move on to the next problem. Number 16. All right, let's do 16. 16 on this piece of paper over here. 16. Designing a can. What are the dimensions of the lightest open top right circular cylindrical can that will hold a volume of 1,000 cubic centimeters? Okay, so first of all, I know the volume has to equal 1,000 cubic centimeters. Okay, and then I want a can that is open. Here's my right circular cylinder can that has a radius r, and I know that the top is open. Okay, and so for the record, we want to minimize the lightest. So if I want it to be the lightest, that means I have to have the least material. So I'm going to minimize surface area again. Okay, so the surface area of a right circular cylinder. Now let me get a piece of paper here that's small enough for you to see on the screen. And I did this in class before. Okay, so let's say I have a cylinder, right? Here's my cylinder. And I want to find out what the surface area is. Well, it's open. This one is open, right? So I have a solid base here, and I have to have the area of the base, which is a circle. So the surface area is going to be 1 pi r squared because the open top is open. So I'm not including the top. Then I have to have the surface area of the cylinder. Well, if you were to unzip it, you get a rectangle, which is pretty amazing. Okay, so the area of a rectangle is length times width, but the width here is the height of our right circular cylinder. Okay, so the length is going to be the perimeter, the circumference of the circle here. Okay, so it's going to be 2 pi r times h. So plus 2 pi RH, and that's the area of this part of the cylinder, okay? Well, here we go again. I've got too many variables on the right-hand side of this formula, but I know a volume. And volume, believe it or not, of a cylinder, volume equals pi r squared times h. And I know that to be 1,000 because that's what they told us. Okay, I have too many variables here, and I can either solve for r, which would involve square roots, or I could solve for h, which doesn't. So I'm going to solve this for h. So h is going to equal 1,000 over pi r squared. And I'm going to take this information and substitute it in for h. So we're going to get surface area equals pi r squared plus 2 pi r times h, which is 1,000 over pi r squared. So we're going to reduce this. So let's reduce it. Surface area equals pi r squared plus, this is going to be 2,000 pi here. So 2,000. But I can get rid of this pi and this pi. And I can get rid of one of the r's. Okay, so it's going to be 2,000 over r, which equals pi r squared plus 2,000 r to the minus 1. That's what I want to take the derivative of. Okay, so SA prime, surface area prime, is going to equal the derivative of pi r squared, which is 2 pi r, minus 2,000 using the power rule, 2,000 r to the negative 2. Putting things where they belong, it's going to be 2 pi r minus 2,000 over r squared. Finding a common denominator, it'll be r squared. So I multiplied this by 2 pi, this 2 pi r times r squared over r squared, which gives you 2 pi r cubed minus 2,000. I'm going to set that derivative, SA prime, equal to 0. If r is 0, I don't have a can. So that's not going to be a possibility as one of my answers. So I set the numerator equal to 0, which is 2 pi r cubed minus 2,000 equals 0. I get r 2 pi r cubed equals 2,000. R cubed equals 2,000 over 2 pi. Now, I am only going to reduce this by 2. I'm going to make this 1,000 over pi, right? Because I can get rid of the 2. And then I'm going to take the cube root of both sides. Well, the cube root of 1,000 is 10. So this is r equals 10 over the cube root of pi. All right. I'm thinking that's the right answer. It is. It is because the derivative of this is 2 pi. We're good. Okay, so that's r. So let's do a SA prime line. And I put 10 over the cube root of pi. I don't know what that number is. I have no idea, but I know it's 0. And if I superimpose at 0, and I know it's bigger than 0, so if I superimpose the denominator, that's r squared. Here it is, r squared. And if I superimpose the numerator, which is a cubic with n behavior, like so, I can do a sign chart. So I'm going to get out my purple. Let's do a sign chart. I have a positive and a negative. When I divide those, I get a negative. I still have a positive and a negative, so it's negative. And then I have a positive and a positive on this side, so this is positive. All right, so when I do the slope analysis or the first derivative test, I'm going to have a negative slope to a 0 slope to a positive slope, which means I have a minimum, which is what I was after because I want to minimize the surface area of a can, because if I minimize the surface area, I have lighter material usage. Okay, now the question is asking us for what are the dimensions? Well, I know what r is, so I got to find h, right? So if r equals 10 over the cube root of pi, h we know is equal to 1000 over pi r squared, and I'm going to go such that r equals 10 over the cube root of pi. So let's plug that in. We're going to say h equals 1000 over pi times r squared. Well, r squared is going to be 100 over the cube root of pi quantity squared. Because I just, right? So if I keep change flip, well, actually I can reduce the 100. And I'm going to get 10 over pi times, this is going to be pi to the 2/3, right? Because it's cubed, the cube root, and it's squared. So it's going to be 10 over, when I add the exponents. Oh, this is negative 2/3, right? It's negative 2/3, sorry, because it's in the denominator of the denominator. So this is negative 2/3. So can that be right? They're going to be equal? That's weird. All right, well, let's figure it out. That's going to be pi to the 1/3, which is the same as my height, which is weird. Let me check the answer real quick. All right, so what do we do with that? Well, we have to then make a statement. We have to then make a statement and say, well, how do I know that's a maximum? Using words. Because we love to use words in calculus. And this was number 16, right? So I'm just double checking my answer's right. Let's see. Yes, you're right, because it's the same number. Sometimes you get the same number. I should not second guess myself, right? So dimensions, of can, of lightest can, I should say. Lightest can should be r equals 10 over the cube root of pi, and h equals 10 over the cube root of pi, since SA prime was less than 0 and went to SA prime is greater than 0. Okay? They're not pretty numbers, but they work out. So that's good. And my should here is a little bit annoying. All right. That's 16. Let's do 17. 17. We're designing the same kind of can, a right circular cylinder, whose manufacturer will take waste into account. Is it closed? It doesn't say if it's closed or open. You are designing a 1,000 cubic centimeter right circular cylindrical can whose manufacturer will take waste into account. There is no waste in cutting the aluminum for the side, but the top and the bottom of radius R will be cut from squares that measure 2R on units on each side. The total amount of aluminum, so this is aluminum, equals 8R squared plus 2 pi RH. I was going to put a square there, but it's H. All right. Rather than the one in example 4, we want to find the ratio of H to R, which means whatever I find for H, I'm going to put it over R and see what ratio I get. Now, they told us the volume of this same cylindrical thing here is what? Pi R squared H, but they tell us again it's 1,000. So I'm going to do the same thing and solve for H because I don't have to square it or anything when I plug it in here. So we're going to let H equal 1,000 over pi R squared, and we're going to substitute in. We get A equals 8R squared plus 2 pi R times H, which is 1,000 over pi R squared. I'm going to reduce by a pi, and I'm going to reduce by an R. And we get area equals 8R squared plus 2,000 over R. So area equals 8R squared plus 2,000 times R to the minus 1, right? And so we're going to take the derivative of that. A prime is equal to 16R minus 2,000 R to the minus 2. Putting things where they belong, I get 16R minus 2,000 over R squared. Got to set it equal to 0, finding a common denominator, which is R squared. I multiply 16R by R squared over R squared to get 16R cubed minus 2,000. And if R is 0, guess what, folks? Do we have a can? The answer is no. So I'm going to set the numerator equal to 0. 6R cubed minus 2,000 equals 0. R cubed, 16R cubed equals 2,000. R cubed equals 2,000 over 16. Now I know there are some perfect cube factors in these two numbers, so I'm only going to reduce these by 2. And this is the reason why. R cubed equals 1,000 over 8. Because, you know, that's easier for me to see. What's the cube root of 1,000? Oh, I heard it from the back of the room. It's 10. And the cube root of 8? Oh, that's 2. And see, I see that that's 5. Okay, so R is 5. So what's H? It means H is 1,000 over pi and R squared, such that R equals 5. Sorry about that. I had a brain fart for a moment. Okay, so it's 1,000 over 25 pi. Okay, so let's see. 25 goes into 100. 25 goes into 100 8 or 4 times, right? And there are 10 100s in 1,000, as I recall, right? So it's 48, right? So let's try it again. 25 into 1,000. 25 goes into 100. 25 goes into 100 4 times. So that's going to go into it 40 times. Sorry, it's late. This is 40 over pi. Okay, so that's H. All right. So if I want the ratio, question's asking for the ratio of H to R. Well, H over R, that's a ratio. So let's put it in there. That's going to be 40 over pi divided by 5, which is really over 1. So I can change flip. So this is 40 over pi times 1/5, which means it's 8 over pi. And that's the ratio they're looking for. But How do I know that this is a minimum? Well, because I'm going to do a prime line. And what am I putting on it? I'm putting r equals 5. That's a 0. And at 0, I have an undefined, so that's going to be my parabola. And again, this is a cubic, so I'm going to superimpose the cubic derivative, and I'm going to do my sign chart. Here we go. I have negative and positive. When I divide them, I get negative. Positive and negative divided is negative, and then I have positives over here. So that means that I have another minimum situation here. And we will say that we have minimum aluminum usage. No, I don't know how to spell usage when r equals 5 and h equals 40 over pi, since a prime is less than 0 and goes to a prime is greater than 0 at those two values, okay? But the question's asking for the ratio of h to r, so that's why it's a weird number, 8 over pi. All right, number 20. I think 20 is the hardest one in the homework. Okay. I went too far. That's 19. Quickest route. This is number 20. Jane rows. Okay, Jane is 2 miles offshore in a boat. So here's Jane's boat with her nice little flag. Jane's boat. She's 2 miles offshore in a boat and wishes to reach a coastal village 6 miles down a straight shoreline from the point nearest the boat. So here's my river, or my shoreline, and this is the river that she's in. Okay, so she is how far? It says 2 miles. So this is 2 miles. But from this point here, it says she wants to reach a coastal village 6 miles down a straight shoreline from the nearest point to the boat. So here's my village, right? The village, for V for village. And this is 6. This whole distance here is 6. Miles. She can row 2 miles an hour and can walk 5. Where should she land her boat to reach the village in the least amount of time? So what are we minimizing? Time. So I need a time equation. Okay, so she's going to row her boat somewhere and land it over here somewhere, wherever this landing point is, right? And we don't know where she's going to land. But I know that there's an easy way to solve things in a more difficult way. So I'm going to call this x. This distance from here to here, I'm going to call x. I think that's the easier way to go. And if you do that, this distance here from here to the village is going to be 6 minus x. I hope you agree with that. And so if this distance is x and this is 2 miles, and we know that this has got to be a right triangle, what's this distance? Well, it's going to be x squared plus 4 square rooted. Right? Because you go x squared plus 4 equals that squared. Okay? So these are all distances. Well, Mrs. Muller, that doesn't help us because I need time. Well, time. Well, distance back in Algebra 1 is equal to rate times time. So if I want an equation full of time, I'm going to do distance over r equals time. So the distance she rode over the rate she rode is going to be, so we want a time equation. Here it is, t. So how far did she row? She rowed the square root of x squared plus 4. Well, how fast did she row? Well, the question says she can row 2 miles an hour, so I'm going to put the 2 on the bottom here. So that's the distance over the rate. So the distance she rowed over the rate she rowed. Plus Well, she walked this distance, which is 6 minus x over the rate that she walked. It says she can walk 5 miles an hour, so I'm put a 5 here. Now, I'm going to simplify this a little bit because the derivative will be easier that way. So we're going to say 1/2 times x squared plus 4 to the 1/2 plus 1/5 times 6 minus x. Or we can just divide by, let's just divide by 5 and be done with it. We can say it's 6/5 minus 1/5 x. All right, now we're going to go t prime. So t prime, the derivative of this is going to be, I'm going to go power down, which is 1/4, function, which is x squared plus 4, lower the power 1 to the negative 1/2, times 2x, the derivative of the inside. The derivative of 6/5 is 0. The derivative of a negative 1/5 x is negative 1/5. Now I'm going to put things where they belong. So this means I'm going to have 1 over 4 times the square root of x squared plus 4, because that belongs in the denominator, times 2x. Well, I can reduce that, can't I? I can make this a 2 and this a 1. So I'm going to put an x up here. And we'll put a 2 down here. And this is x, right? Because 2x over 4 is x over 2. All right? Minus 1/5. That's my derivative. I've got to set it equal to 0. Got to find a common denominator. Well, the common denominator in this case is, I'm going to multiply them together. It's going to be 10 root x squared plus 4. All I did was multiply these two denominators together. Okay, what does this denominator not have? Well, it doesn't have a 5. So I have to multiply this fraction by 5 over 5. So I get 5x minus, well, this one doesn't have a whole lot, does it? Certainly not. So I'm going to multiply it by this part, which is 2 root x squared plus 4, and that equals 0. Now, x squared plus 4 is never 0. It's a quadratic that's shifted up 4. If you think about it, that graph, it's up 4, it's always positive, never negative. So our only hope is setting the numerator equal to 0. So we get 5x minus 2 root x squared plus 4 equals 0. I'm going to move the root part of this equation to the right. So this will be 5x equals 2 root x squared plus 4. Now I'm going to square both sides because I got to get rid of that square root to solve for x. Squaring both sides, we're going to get 25x squared equals 4 times x squared plus 4, right? Because when you square a square root, it goes away. So I'm going to distribute. We get 25x squared minus 4x equals, 4x squared plus 16. Subtract the 4x squared, and we get 21x squared equals 16. X squared equals 16 over 21. X equals, the square root of 16 is 4 over root 21. And it's plus or minus. Okay, so now I'm going to do a prime timeline. And what goes on there? Well, the negative 4 over root 21 goes there. And then the positive 4 over root 21 goes on there. And then this derivative here, I'm not comfortable necessarily, graphing that. So I'm going to plug a number in the interval here. So what happens when I let x equal 0? Well, that goes away. So it's going to be 0 minus 2 times the square root of 4. So that's minus 4. So it's negative in here. All right. And I know my time isn't going to be negative. I think it's not going to be this one. But anyway, so let's plug in a big number, like, I don't know, 100. But I plug 100 and I get 500 minus 2 times the square root. Well, 10 is okay too. Let's do 10. 50 minus 2 times the square root of 104. 104 is just over 10, right? Because the square root of 100 is 10. So the square root of 104 is just a little bit over 10. So this is going to be 20-something. 50 minus 20-something is definitely a positive number. Okay? So my sign chart's telling us that we have a negative slope, 0 slope to a positive slope. So I have a minimum here in time at 4 over root 21. So we got to recall what the question's asking us. Where should she land her boat? So this is what x equals, right? So she should land her boat. So we're going to say, I'm going to put my answer up here. Jane should land her boat 6 minus 4 over root 21 miles away from the village to minimize her time of trip. Since t prime is less than 0 and goes to t prime is greater than 0 when x equals 4 over root 21. So that's the hardest problem on the homework, I think, because you have to remember that distance equals rate times time, and time is distance over rate. And that helps you create a time equation in order to take a derivative, okay? All right. That was number 20. Number 22. Maximizing volume. Find the dimensions of a right circular cylinder of maximum volume that can be inscribed in a sphere. All right, what's tough about this one is I've got a sphere here, right? And the sphere is a radius 10, so sphere has a radius of 10. And so here's my cylinder that I'm putting in here. And it's not going to be a perfect picture. I'm just not going to lie. It's just not going to be. There it is, right? And what's hard about this question is, right, we want to maximize it says maximum volume of the cylinder. Well, what is that volume? Volume is pi r squared h, where this is r and this is h. Okay, now they gave us the sphere radius of 10. Okay, so I want you to please think of a way that I could somehow use the radius. Well, guess what, folks? We're going to have to use the diameter to help us out here. So I'm going to suggest to you that inside the cylinder, there's a diameter. Okay? Now, how do I show you that on paper? Okay, well, let's pretend that my tape here is a cylinder. Do you agree that this is a cylinder? A cylinder, yeah, that's a cylinder. Okay? And there's a triangle sitting in there somewhere. And I'm going to create one real quick with my scissors, my handy dandy scissors. This is like, and how tall does it have to be, maybe? Okay, so there. Okay, here we go. We're going to create my triangle. Now, it may not be perfect, but, it's late at night. Here we go. There's my triangle that's in there. Do you see it? If I turn it a little bit, do you see that I have a triangle? You're like, yeah, okay, this is, well, you're a silly girl. I'm going to hold it in here. Do you see that I have a triangle? If I have that on the base, and if I tilt it a little bit, you can see the triangle, okay? And so you can see that it's touching at the top of the cylinder and it's at the bottom of the cylinder. So that's kind of what I'm doing here, okay? But there's a triangle here, right? So this triangle in the cylinder, here we go, has a height of h. This triangle I'm going to lay out on the ground here or on the side. Has a this is h. Okay, so let's talk about what the hypotenuse is. Well, the hypotenuse is the diameter of the sphere. So if the radius is 10, the diameter is 20. So this is 20 from here to here using that. Okay, so this is 20. All right, and what is the bottom here? Well, that looks like it's 2r. It's the radius of twice the radius of the cylinder, right? If I were to pull this out, you see that this bottom part here is twice the radius of the cylinder. I hope you can see that, right? Do you see that? Halfway. All right, so I have an equation here. Nice, spontaneous prop at my desk here. So I have an equation here. I can say that h squared plus 2r quantity squared equals 400. So this is h squared plus 4r squared equals 400. Now, there's an easy way to go and a difficult way to go. Now, do you notice in this equation and this equation, I have a similar term. I have r squared, and I have an r squared here. So I'm going to solve this equation for r squared. So it's going to be 4r squared equals 400 minus h squared. R squared equals 100 if I divide by 4, minus 1/4 h squared if I divide by 4. So I'm going to plug this in for r squared. So volume equals pi r squared, which is 100, minus 1/4 h squared times h. And now I don't want to use the product rule here, so I'm just going to multiply it out. So we're going to get volume equals pi on the outside here, 100h minus 1/4 h cubed. All right. And v prime is just going to be pi times 100 minus 3/4 h squared. I'm going to set this equal to 0. I get 100 minus 3/4 h squared equals 0. I get 3/4 h squared equals 100. H squared equals 400 over 3. H equals, the square root of 400 is 20. So it's going to be plus or minus 20 over root 3. If I do a volume prime line, here it is. I'm going to put negative 20 over root 3. And I'm going to put a 20 over root 3, 0. And then we're going to superimpose our graph on here. Our graph, believe it or not, is our derivative graph is a parabola that opens upside down. Here it is upside down. Okay? I'm going to do a sign chart, which is negative, positive, negative. All right? I can't have a negative height, so I knew this wasn't going to be the answer, but I have a positive slope to 0 slope to a negative slope, which makes this a max. And I can then say that the question's asking for what's the max volume, right? So max volume of, and I don't know what it is yet, so I'm going to calculate that in a minute, is max volume of flop when h equals 20 over root 3, since v prime is greater than 0, and then v prime goes to less than 0. Okay, so how do I find the maximum? If I know x, I've got to plug it in my equation here to find the max. Okay, I'm going to plug it into this one, I think. Okay, so volume of 20 over root 3 is going to equal pi times 100 times 20 over root 3 plus 1/4 times 20 over root 3 cubed. So let's see what that is. That's going to be pi times, this is going to be 800, no, 200, I'm sorry, 200 over root 3 plus 20 cubed. 20 times 20 is 400 times 20 is 8,000 over, well, root 3 cubed is root 3 times root 3, which is 9 times root 3. So this is 36 root 3. Oops. With 36 and 36. Okay, let's see if that's right. That's 100 times that minus 1/4 of that. Okay, so when I add like terms here, I got to multiply 2 times 36, right? Which is 70. Let's do it. 200 times 36 is 7,200. So this is pi times 7,200 over 36 root 3 plus 8,000 over 36 root 3. So they have the same denominator now. So that's going to be 15,200 pi over 36 root 3. So 15,200 divided by 36 doesn't go nicely. I'm getting 3,800 pi over 9 root 3. All right, so let's see what the right answer is. I got to check that because I should have my tab thing on the right answers, right? That would be nice because I could be more efficient in my video. Well, I've got to put a tab on here. All right. This is number 22. So let's look at 22. 22 says, oh, I got to solve for the, no. 20 root 3 is the height. And it says the max volume is 4,000 pi over 3 root 3. So I did something wrong in my multiplication. Let's see here. If I go 100 times 20 divided by second root 3, close the root, plus 1 divided by 4 times parentheses 20 divided by second root 3, close the root, parentheses to the third. Oh, wait. I put a plus here. Silly girl. Of course, it's 8,000 root 3 over 9. All right, let's see. What did I do here? That's 4r squared equals 400. 4r squared equals 400 minus h squared. R squared equals 100 minus 1/4 h squared. I agree with that. Take that, plug that in here. 100 minus 1/4 h squared times h gives you 100. And then 100h minus 1/4 h cubed. Take the derivative. I get 100 minus. Oh no, you guys are probably screaming at me, weren't you? No, well, the derivative is what? I bring this down 3/4 h squared. That's okay. And I move this over. H is definitely 20 over root 3, which is good. I got that right. Okay, so I got to take that h and plug it in to my equation, right? So let's plug it in. I'm going to go. I'm going to plug this equation into my calculator. So I'm going to go second pi times parentheses 100 x minus 1 divided by 4 x to the third such that x equals 20 divided by second root 3, close the parentheses. Where did I? Uh-oh. All right, well, I think I disagree with the answer key, basically. But we're gonna have to be all right with that. I think the answer should be this 4,000 pi, since I can't seem to plug this in all right. This is 36 times 200. 2,000. This is 2,000. 2,000. I'm sure you were screaming at me the whole time, right? 2,000 times 36 equals, I have to have another 0 here. Tricky, right? Plus 8,000 equals 8,000. Divided by 36. All right. Well, okay. You know what? I'm too tired to think about too tired to think about that. 20 cubed. 20 raised to the third is 8,000. That's right. Root 3 cubed. Root 3 cubed. Second square root 3 raised to the third is 3 root 3. Oh, this is 12. This is 12. That makes a big difference. Oh my goodness, that makes a big difference. Okay, you guys are going to have to forgive me because I'm tired. It's 11:15 and I'm trying to get it done for you guys. So bear with me. I'm human. Oh my gosh. So 2,000 times 12 is 24,000. This is a 12. So 24,000 plus 8,000 is 32,000 pi over 12 root 3. And I divide this by 12, and I get 8,000. Over 3 root 3. Now, why would I have to divide that by 2? All right, well, we're going to have to go with that because I got to keep moving on at 11:16. 22. I'll owe you that one. 22, 24. 24 says maximizing profit. Okay, so what we have to know here is profit equals revenue minus cost. Okay, so profit's going to equal, in this case, x squared over x squared plus 1 minus x minus 1 cubed over 3 plus 1/3. Okay, now, if I want profit prime, we're going to have to do quotient rule here, which is ho, d high, which is 2x, minus high, which is x squared, d ho, which is 2x, all over ho ho, which is x squared plus 1. Ho d high minus high d ho over ho ho. Minus, and this is 1/3 really, because I could rewrite this as 1/3 x minus 1 to the third, right? So power down, which would be 1/3 times 3, which is the same, x minus 1 quantity squared, plus the derivative of the times the derivative of the inside, which is 1, right? Plus the derivative of 1/3, which is 0. Okay. All right, now I'm going to simplify this numerator. I can factor a 2x out of the top right here, and I'm left with x squared plus 1 minus x squared all over x squared plus 1 quantity squared minus x minus 1 quantity squared. So this is x squareds are going to cancel, and I'm left with 2x over x squared plus 1 quantity squared minus x minus 1 quantity squared. Now, this is going to have to be a calculator question because to find a common denominator, that's easy enough. This is going to be 2x minus x minus 1 quantity squared times x squared plus 1 quantity squared over x squared plus 1 quantity squared. And, you know, multiplying that out is just a nightmare. So what we're going to do is we're going to set the numerator equal to 0 and solve it, okay? So how do we do that? We're going to say F2 solve the 2x minus parentheses x minus 1 raised to the second times x to the second plus 1 raised to the second equals 0, comma, solve it for x, close parentheses, boom, enter. And so hopefully we'll get an answer here. X equals, it's thinking, all right, so we're getting x equals 0.2941, 0.2941, and then we're getting x equals 1.52. Okay, now the question says is this is in thousands, right? But I'm still going to do a sign chart because these are not nice numbers. I'm going to put 0.294 and I'm going to put 1.525 on here. All right, now I'm going to plug 1 in because 1 is a nice number in the middle here, isn't it? Wouldn't you say? So in my mind, I'm plugging in 1. That's going to be 2 minus, this goes to 0. So it's going to be 2 over 1 plus 1 is 2. 2 squared is 4. So it's a positive number. Whatever this is positive. Okay, so let's plug in, I don't know, let's plug in 3. This is 6 minus 2 squared, which is 4, 4 times 10, which is 40. So this is a negative number over on this side. So this is a minimum. And then let's plug in 0. We get 0 on here. This is always positive. And then I get a always positive, always positive. So it's negative over here. Oh, wait a minute. I just did that and it's a max, right? Because it's plus 0, negative. This is a minimum. Okay, so we are going to say production level of x equals 1.525 thousand units maximizes revenue. Maximize profit, I'm sorry. Maximizes profit. Since P prime is greater than 0 and then goes to P prime is less than 0 when x equals 1.525 thousand. Okay? All right. 36. We're on a roll here. Okay, so 36. I like 36 because, 36 kind of really helps point out in your picture. It tells you a lot. So it says find the volume of the largest right circular cone. So the volume of the cone is equal to pi over 3 r squared h. It's a third of the cylinder, okay? I got too many variables here. But I want you to please notice we can use Pythagoras to help us eliminate some of the variables, okay? But we have to figure out what r is in terms of x and h. So r is of the cone, r is x. H is equal to y plus 3. I hope you can see that the h of the cone is y plus 3 and the r is x. And we know that x squared plus y squared equals 9 in this case because of the right triangle relationship here. So I'm going to write the volume as pi over 3 x squared, because r is x, times y plus 3. Now I want you to notice in this equation what's similar. I have an x squared in this one and I have an x squared in this one. So we're going to solve this for x squared, which is equal to 9 minus y squared. I'm going to use this substitution in here. We're going to volume equals pi over 3 times 9 minus y squared times y plus 3. I'm going to multiply it out. I'm not going to use the product rule. So here we go. 9y plus 27 minus y cubed minus 3y squared. All I did was just distribute, the pieces here, right? That's all I did. All right, volume equals pi over 3 times, I'm going to put it in order, negative, well, I can just take the derivative here. Let's do v prime. This is 9, derivative of 27 is 0, minus 3y squared, minus 6y. Set it equal to 0. We get pi over 3 times, this is negative 3y squared. Well, let's put them in order. 9 minus 6y minus 3y squared equals 0. All right, we're going to factor this. Oh no, factoring. What are the factors of 9? Well, it's 3 and 3 maybe. And the factors of 3y squared? Well, it's 3y and y. And now we have to have the inner product, which is 9y and 3y, somehow add up to a negative 6. So the negative is going to be on the 9y and the positive is going to be on the 3 here, okay, or the y. So my zeros are going to be, well, 3 minus y, it's going to be y equals 1. Because when y is 1, that's 0. And then y equals negative 3. Now, negative 3 is not going to work, right? Because you can't have an h of 0. But we're going to do it on our sign chart anyway. So v prime line here, we're going to put in negative 3 and 1. Those are the zeros, and I'm going to superimpose a negative parabola on here. Here it is, my negative parabola. And my sign chart is going to be negative, positive, negative. And if I do my analysis here, this is a negative slope to 0 to positive, positive to 0 to negative, and I have a max and a min. And I want to maximize the volume. So my maximum occurs when x is 1, when y is 1. And I want to find the max volume, right? So max volume of, well, let's figure that out when y equals 1, since v prime is greater than 0 and then goes to v prime is less than 0. So I need the volume. So volume is equal to pi times, I'm going to put 1 in for y. This is v of 1. I'm going to use the one with the y's in it, which is this one. So 9 minus 1 squared, which is 1, times 1 plus 3. Right, so v of 1 is going to equal, this is pi times 8. Oh, this is pi over 3. Sorry, pi over 3. Times 8, times 4, which is 32 pi over 3, 32 pi over 3 units cubed. Okay? So that's how you do it. That's 36. 41. Calculus and geometry. How close does the curve y equals x, square root of x, come to the point 3/2 0? Okay, so I have a curve here, square root of x, and I want to know the closest point on that curve xy to this number here. So I'm minimizing distance again, right? The distance formula is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, I'm going to plug in what I know. This is equal to x comma root x because y is root x. Okay, so the distance is going to equal the square root of x minus 3/2 quantity squared, because I'm subtracting the x's, plus root x minus 0 quantity squared. So this is d equals square root of x minus 3/2 quantity squared plus x, because square root of x squared is just x. All right, now I'm going to take the derivative of this by rewriting this as x minus 3/2 quantity squared plus x raised to the 1/2. Actually, I'm going to make this big D if that's all right, so I can get my variables in better shape here. So I'm going to make this big D for distance. Okay, so we're going to do D prime, which is equal to power down 1/2 function, which is x minus 3/2, quantity squared plus 1. Oh, try again. Plus x. Lower the power 1 to the negative 1/2 times the derivative inside, which requires a chain rule here. So it's 2 times x minus 3/2, lower the power 1 to the first, times the derivative of the inside, which is 1, plus 1, because the derivative of x is 1. All right? So this is going to be what goes in the denominator is this piece, so it's going to be 2 root x minus 3/2 squared plus x. And this is just the distance. And we know the distance is not going to be 0. And then I get in the numerator 2 times x minus 3/2 plus 1. And I'm going to set this equal to 0. So when the numerator is 0, it's going to be 2x minus, I'm going to distribute this, and we get 2x minus 3 plus 1 equals 0. So that's going to be 2x minus 2 equals 0. 2x equals 2, x equals 1. So the point's going to be 1, 1. Right? Because, you know, the point is x root x. Right? So it's going to be 1, comma 1. Can it be that simple? Well, we need the minimum distance. That's what the book's asking for, right? So first of all, how do I know that's a minimum? I'm going to do a D prime line. Here it is. I'm going to put 1 on it. And this is a line with a positive slope. And my sign chart is going to be negative, and then it's going to be positive. And so I know that I have a negative slope to 0, slope to positive. So I definitely have a minimum here. Right? Because this numerator is a line. That's a line. So I have a minimum. And so if I want the distance, remembering I want the distance at 1 when x is 1. So I want to evaluate it at 1. So it's going to be the square root of 1 minus 3/2 quantity squared plus 1. Because x is 1, right? Because I'm using this formula here. So the distance of 1 is going to be the square root of 1 minus 3/2 is negative 1/2. Quantity squared plus 1. 1/2, negative 1/2 squared is 1/4. Right, because it's going to be a positive. This is the square root of 1/4 plus 1, which is the square root of 5/4. Right, because this is 4/4 plus 1/4 is 5/4. This is the square root of 5/2 is the distance, minimum distance. Of root 5/2. Since we're going to say d prime was less than 0 and went to d prime is greater than 0 when x is 1. All right. All right, 40 or 53. 53. 53, let's see here. All right, 53 says two positive numbers have a sum of 60. Sum of 60. So x plus y equals 60. And so I can say that x plus y is 60. And then it says, what is the maximum product of one number times the square of the second number? Okay, well, I can say that one number is x and the other one's 60 minus x, right? So I'm going to say product is equal to one number, and I'm making that number 60 minus x, times the square of the second times x squared, right? Because we could say this equals y times x squared, right? And y is equal to 60 minus x. So I'm not going to use a product rule and multiply that out. 60x squared minus x cubed. Product prime is equal to 120x minus 3x squared equals 0. I'm going to factor out a 3x, and I'm left with 40 minus x. This is 0, so I get x equals 0 and x equals 40. Let's do my sign chart for p prime. What goes on it? The 0 and the 40. And the derivative is an upside down parabola again. So here we go, upside down parabola again. These are zeros. My sign chart says negative, positive, negative, which means I have a maximum at 40 and a minimum at 10, and I want a maximum product. So since this is multiple choice, I don't have to justify it. So I'm going to say the product is equal to 60 minus, well, what is x? X is 40. 60 minus 40 times 40 squared. So P equals, that's going to be 20 times 1,600, right? Which is a big 32,000. So there you go. That's the product of the number, all right? Now I'm going to be quickly moving to 4-6, number 18. This is a related rate, and hopefully I've got it right behind here. So let's look at 18. 18 is the hemispherical bowl. Okay, I'm going to make it a little bit bigger. Now, the tricky part of this is knowing that, okay, so the question says water is flowing at a rate of 6 cubic meters per minute from a reservoir, which means the reservoir is draining. So dV dt is going to equal negative 6 cubic meters per minute from the reservoir shaped like a hemispherical bowl of radius 13. So the radius here, this of the bowl is 16, or 13, I'm sorry. Shown in the profile. Answer the following questions given that the volume of the water in the hemispherical bowl of radius r is, okay, so they're telling you that the volume is equal to pi over 3 y squared times 3r minus y. Now the tricky part to this question is this big R, they're telling you because our hemispherical bowl, big R is 13. So that's constant. So this R is going to be 13 because that's the radius of the hemispherical bowl. So this is y squared times 39 minus y. Okay? If the bowl had a different radius, like 20 or something, that's what you would plug here. And that stays constant because the bowl's radius is not changing. Okay? All right. So what's changing with respect to time in this picture when the water's draining from the tank? Well, clearly R is going to get smaller as the water level drops, and so will Y. So R is a function of, little r is a function of time, and so is Y. Okay? So, Part A says, at what rate is the water level changing when the water is 8 meters deep? So my Snapchat moment is when y equals 8 meters. Okay? So I have dv dt, which they gave me, and I have one variable over here, so I think I'm okay. But I don't want to do the product rule. I want to multiply it out. So I'm going to say v equals pi over 3 times 39y squared minus y cubed. Okay? Now I'm going to take the derivative implicitly with respect to time. So I'm going to take the derivative of this with respect to time. So we're going to get dv dt equals pi over 3 times, well, that's going to be 78 y dy dt minus 3y squared dy dt. And I'm solving for dy dt. I need to know what dy dt is. Okay, so I'm going to factor out a dy dt. I'm going to get dv dt times 3 divided by pi. I'm just dividing, by 3 and multiplying by 3 and divide by pi. And I'm going to get a dy dt, factor it out, and I'm left with 78y minus 3y squared. And dy dt then is equal to 3 dv dt over pi times, I'm going to divide by this, 78y minus 3y squared. I'm going to go such that y equals 8. So that's going to be 3 times negative 6 over pi times 78 times 8 minus 3 times 64. All right, so that's negative 18 over pi times, I'm not going to do that in my head, 78 times 8, which is 624 minus 64 times 3. This is 432. And my calculator, which is so nice, will reduce that for me and give me an exact answer. So negative 18 divided by 432 is negative 1 over 24. So this is equal to negative 1 over 24 pi. And since y is a linear unit, this is going to be meters per minute. That's dy dt. Okay. And did I expect it to be negative? I surely did, because the y is decreasing. So that makes sense. Part B. Part B says that what is the radius r of the water's surface? This is little r. When the water is y meters deep. So is there a relationship between little r and y? Well, what's hard to see about that is this distance right here is going to be 13 minus y, because this from the center of the sphere to the edge here is 13. So this right here is going to be 13 minus y. So I'm going to have r squared plus 13 minus y quantity squared equals 169, okay? So it's going to be 13 minus y squared. I'm sorry, 13 minus y quantity squared, because that's the length of the side, plus r squared equals 169. So if I want to know what is the radius of the water, r, if I'm going to solve for r, we're going to get r squared equals 169 minus 13 minus y quantity squared, okay? So r is going to equal the square root of 169 minus 13 minus y quantity squared. And they want to know an expression for r. Well, we just got that. Part C, at what rate is the radius changing when the water is 8 meters deep? So they want to know what the rate of change is at our Snapchat moment. So I got to take the derivative of this with respect to time for part C, right? If I take the derivative of that with respect to time, that's going to be power down. So dr dt is going to equal 1/2 function, which is 169 minus 13 minus y squared to the negative 1/2 times the derivative of the inside. Well, the derivative of the inside, hold on, let me make this clearer. I want to do it on a separate sheet of paper here because I'm running out of space. You know, running out of space is not a good thing. So we're going to do it up here. So dr dt is equal to, you know what? I may just take the derivative of this. Okay, are we all right with me taking the derivative of that? Do I know what r is? No. I'll just do this. Okay, so it's going to be 1/2 169 minus 13 minus y quantity squared, lower the power 1 to the negative 1/2, times the derivative of the inside. Well, the derivative of the inside is the derivative of 169, which is 0, minus 2, 13 minus y, lower the power 1 times negative 1, dy dx dt. Okay? So let's put things where they belong. dr dt equals, well, this 2 and this 2 are going to cancel. And the negative and the negative are going to cancel. So I'm going to get 13 minus y times dy dt over, right, because I have this and this now in the numerator, the square root of 169 minus 13 minus y quantity squared, such that y equals 8. And we know that dy dt is what we solved for originally, which is negative 1 over 24. Let's plug in what we know. dr dt is equal to 13 minus 8 times negative 1 over 24 over the square root of 169 minus 13 minus 8 quantity squared. So let's simplify that. 13 minus 8, I believe, is 5. So this is negative 5 over 24 over the square root of 13 minus 8 is 5. So this is 169 minus 25, which is, I believe, 144. Square root of 144 is 12. So this is negative 5 over 24 over 12 over 1. If I were to keep change flip, we would get negative 5 over 24 times 1 over 12, which is equal to negative 5 over 24 times 12. I'm not going to do that in my head. Sorry. 24 times 12 equals 288. And this is dr dt, which is also a linear measure. So this would be meters per minute as well. That's dr dt. But the question says, at what rate? So we're okay. So it's not speed. All right. Well, thank you for putting up with me. I apologize for number 22. And I need to figure that out as to why I'm not matching the answer key. But the process was right? Setting up the pi r squared h using the Pythagorean theorem for what you're going to use to solve for and plugging it in here. And then I know that this H is right. For some reason, I'm not finding the right volume. Right? But anyway, you guys have a great day, afternoon, evening, whatever it is that you're doing. And know that optimization is very difficult. And give yourself a little bit of a break and understand that. And everything's going to be all right. We will talk to you later. Thanks for listening.